We're talking about logarithms and logarithmic functions, and we want to use inverse properties to find inverse functions. Evaluate each expression using inverse properties. So these are some log rules that we just have to remember. If we look at example A, we have 8 raised to the log base 8 of x. In this case right here, we have 8 raised to the log of base 8. We can take our x value and we can move it out front of the entire expression. So we get x 8 log 8. And in this case, 8 log 8, that is equal to just 1. So our solution, we can get x times 1, which is just equal to x. We have a similar situation over here. We have log base 7 of 7 raised to the negative 3x power. So in this case, we can move our exponent out front of our log, and we can write it as negative 3x multiplied by log base 7 of 7. And this right here is just equal to 1. So we get negative 3x times 1, which is just equal to negative 3x. Now, if you look at example C, that one was going to be a little bit different. We're going to have to use common bases to solve this one. So we already have our x variable, so we're going to add a y variable here. And we remember that our base is 2, so we can rewrite this in exponential form. So we can say 2 raised to the y power is equal to 64x. And now we can get it in common bases. So we have a base of 2 over here. Well, how do we get 64 to become 2? So we can just do 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 1, 2, 3, 4, 5, 6. So 2 to the 6th power is the same as 64, so I can rewrite that. I'm going to leave a little space here. So 2 to the 6th power, that's the same as 64 raised to the x power there. And now, because we have the same base on both sides, I can take the log base 2, the log base 2. I can do the log of any. I can take the log of 3, I can take the log of 10, I could take the natural log. The reason that we took the base 2 is because there's a log rule that if we have the log base 2 of the same value, that's going to be equal to 1. So in both cases, we can take the exponent and we can move it to the front of the logs. So here we get y multiplied by log base 2 of 2 is equal to 6x times the log base 2 of 2. And remember that that is equal to 1. And that is also equal to 1. So then we get y is equal to 6x. In this case, we have e to the natural log Remember that the natural log, another way that we can write that is e log base e of 20. So we can take the 20 and we can move it out to the front of the e. So we have 20 times e log e. In this case, we know that this is equal to 1. So we have 20 times 1, which is just equal to 20.